Well, hello there, everybody, and welcome to SkyTour live stream for this evening, May 29th, 2022. One day away from what could be the biggest meteor shower ever, and we're going to run a stream on that day as well. Just want to let you know that, as always, we have with us our buddy and good friend, Daryl Mason. Hello, Daryl. How are you?
Hello, Mark. I'm good. How are you doing? Hi, everybody.
I'm doing good, thank you. Now, for folks that are just joining us, this is me down in the corner. Hello. And right above me, you can actually see the telescope in the building right there. We can also, if I just tweak the telescope a little bit, I'm going to turn on my hand controller. So now that's the peek into the computer of the telescope right up there that you see. This section up here in the screen right here, this is the telescope control section. Obviously the picture of this telescope, the computer entries. This is our main screen. This is what we're going to view. And this is our camera control section over here. So we're going to be looking obviously in this view all night long. And in addition, we have a wonderful planetarium that we use that controls the telescope. We actually have it hooked into the telescope. And that is this guy right here. So this screen is our current view of the sky. I'm going to just get us back to, this is what it looks like now. We have, I turned off the atmosphere so I can see the stars. But so this is what it looks like now. This is the star Spica in the constellation of Virgo. Virgo the Virgin. And if I back away here and come back in a little bit and I add some constellation art, you can see how Virgo is supposed to be in the sky. There she is right there, and Spica is right here. And so Virgo has lots and lots of galaxies in it, and then up here is Leo the lion. Leo has lots of galaxies. We're going to see some of these tonight. And then further up the north we have Coma Berenices up here. And Coma Berenices also has a wonderful amount of galaxies in it that we're going to look at. I just have it on Spica right now, the bright star in Virgo, because I want to be able to gauge the night. So here we go. This is Spica right here. Right now we're actually, we got it pretty well centered. Okay, this is my centering reticle for it right now. And it's in there, ready to go. And the coordinates are all set. The telescope is tuned. I just have to currently just add one more little thing in here. You'll also notice the music is all new. Tonight is all new music. And we're going to I'm going to tune the guiding system here for just a second here. I also want to thank you guys. I don't know where it came from, but the number of views on the other stream the other night is over 1,200. I'm really happy. Really pleased that we got that many views on one of our streams. And we also have a friend of mine actually out in the audience, guy John. John, welcome. It's his first time watching the stream. He's got it on his TV at his house. I was just over there today. It was a nice picnic, and thank you, John, for that. That was wonderful. He always goes all out for people. All right, let's do this. Let's go to... I'm going to set my guiding rates here. All right, and we're going to do this. And I'll do 15 on that guide rate, and I'm going to go down now to our up and down rate, and I'm going to set that rate to a 17. These are the two numbers that I, through lots of testing, I found were the best. All right, it just basically is a fraction of motion that it's going to do to correct for guiding when we take longer exposures. And I've successfully taken exposures 2 to 3 minutes long each, but I don't do that with you guys because, you know, you don't want to sit around for 2 to 3 minutes. So I find that, you know, pretty crazy, you know. So we are going to look at some beautiful galaxies tonight. We're going to have a chance to do that. And those of you that are out in the audience that want a particular object, if you know this particular part of the sky, please sound off in the chat, and I'll be happy to look at the object if it's up. All right. I know that Daryl has some favorite objects, and I have some favorite objects. But if you have some, please let us know, and we'll be happy to check them out. You're driving the scope tonight. I'm just a spectator like you. You know, not exactly, but you know what I mean. I got everything up and running. It looks like it's working pretty well right now, and I'm really pleased about that. Daryl, you got any ideas after it gets dark enough? If you notice, it's still light up there. You can see that there's still some sky. But,
Yeah.
you know.
Oh,
What do you think?
let me think about it. I don't know. Would you want to try the antenna again?
I do.
Yeah.
I
have
do.
to wait until it gets completely dark, probably.
Yes, we do. Yes, we do. Hi, Fantasy. I want to say hi to everybody, too, that's here. Donald Kunzer, Justin T, JSCO77, Fantasy, of course. Good to see you. David Schmidt was here earlier, and the first one in tonight was Justin T. Nice, Justin. Second was David Schmidt. You guys are diehards. I love it. And CND Boy is here. Great to see you. Happy Memorial Day to you, too. And I wanted to just make sure that all of you know that there's a huge potential meteor storm that's going to start, I think it's tomorrow night, into the next day.
Yes.
And what we're going to do is we're going to run that, but we're going to use the telescope, but we're also going to be taking a movie of the entire night from horizon to horizon. We're going to be using our all-sky camera, and that's really going to show off, and it's not going to miss a thing. It's not going to miss a thing because we're going to take like 25-second exposures all night long, and you'll see hopefully hundreds of streaks on each frame showing the meteors. And actually that stuff will be pretty valuable scientifically because it'll be a stabilized platform from which we can watch these meteors and then review them later. And every frame will be it's not going to have any time in between. It's going to take a frame and keep taking frames one right after the other. We won't lose a single second. So that'll be pretty cool.
All sky cameras still have bird poop on it?
Yes, it does. So I have to have someone go clean it.
Uh-oh.
Yeah. Hello, Daisy and Zoe. Hey, PG. PG, I'll see you next week in New York. And I'm glad you could be here, Fantasy. And Anahata77, Bonnie, hi, how are you? Nice to see you.
Thank you, Justin.
Yeah, and hey, Justin, thank you. That's so nice. I just went down to the bottom and saw that. Thank you very much, Justin. That's awful kind. Izabela, hello.
I'm sorry.
Yeah, go ahead.
Donald asked a question. I believe he did last stream also. Should we take a peek at that supernova tonight? See if it's still there?
Yeah, why not? That's a great idea. What galaxy was that in? Do you remember?
Not offhand, no.
Okay. Well, why don't you look that up in the background then while I
Okay.
just check something out here. I'm going to try and start my focus routine. I should have a number of stars now in here. Yeah, I defocused it a little bit just so I can do this. This is our main view, as you know. I'm going to increase the gain to about 200. And that should be too much, and I have to reduce it a little bit, which I'll do. Actually, 150 is good. All right. And now let me reduce the exposure a bit. Okay, and bring it up gradually and see where that puts us.
Supernova 2022 HRS in NGC 4647.
Okay. Make a note of that, and we'll go there as soon as it's dark.
Okay.
You may remember we actually checked out this supernova, guys. It was actually very visible, and you could clearly see that it was a fairly bright and blue, which makes sense. It was very hot. And blue is hot in Star World.
No, it's
Yep.
in Virgo,
Yep.
so that's where we are now anyway.
No, it's not far.
Remember, right, it's right next to M60.
Yeah. Okay. Well, I remember that. Let's go up to 500 milliseconds, which is half a second, and be ready to see some additional stars. It's 11 p.m. here in the East Coast, 11:13, and as you can see, it's just getting dark, but it gets dark quick. Thank you, Vera. Yes, please don't forget to like and subscribe and share this this stream. We really enjoy it. It's just so much fun to do. And, you know, I'm in Connecticut. That telescope's 2,500 miles away in Arizona, and we're controlling it from here. And what's neat is that technology to do that, most of that technology is absolutely free. Okay? What isn't free, of course, is the time it took to put all this together. So when you guys contribute, it means the world to me. I'm not asking for it. Don't get me wrong, but I'm saying that that means a whole lot when you do. So, but as you know, I'm going to do this anyway, whether you do or not. So it's okay. I just also finished my I finished preparing my talk. I'm doing a talk next week in New York at a conference, and then I'm doing a talk in Roswell, New Mexico after that, and then I'm doing a talk in Denver after that. And this time, what we're going to do is I'm going to talk about how extraterrestrial craft might actually propel themselves, and the science, the actual science that may really exist that supports their passage between the stars, getting to here from way out there, like from not a star like Spica, but maybe one of the fainter ones nearby, you know, because Spica is a little too bright and hot for planets to be life-bearing. Okay.
That's too bad. Spica's, I've said before, you know, it's like a symbol of fertility, I guess. It's an ear wheat in her hand.
Yeah.
You'd think that'd be a good place for...
You would think.
Life.
For life. Yeah. Okay, what we're going to do right now is we're going to go and try our early autofocus. This is something you've seen me do before, but for those who haven't seen it, basically each of those little yellow squares outlines a star, and we are going to, let me increase the gain a little bit more to catch some more stars. And when I do that, we will be able to do an autofocus, but it's still saying too few stars. Let me go up to an 800 millisecond exposure. It'll be a little bright, but let me reset and try to get a median brightness. Okay. All right, this is going to work. Okay, so what I'm going to do now is I'm going to tell the telescope to start scanning inward, and so it's going to change the focus. And as it does, it's going to build a graph down here on the right. Okay, and this graph is going to be like a parabola. It's going to be a curve. At the bottom of the curve is the best focus position. So it's going to take samples from 3 random locations that it notes as stars, and then it's going to take that focal position, and it's measuring the focus over here. All right, and as it does so, it's going to build this curve, and then when it has that curve, it's going to put the best focus line in there. This is the current position, so you can see the focus is getting sharper and sharper and sharper, and it's going to get to a center point and then go further out of focus and make a curve out of this. And it's a really nice thing. I also, if you've noticed, the main screen is now taken up now by almost all camera, and I've moved the housekeeping thing with the computer is going to be over my head now, right up there. Okay, there's our curve. You can see it now. You see that beautiful red curve? This is the best focus position, and we're going to be able to tell it to go there. Now we're all done. It's in green. I'm going to say now go to the best focus position. I do this, and you're going to watch that other line go right across to the worst, and then come back to the best. And if you watch the stars, they're getting out of focus, and then they're getting into a position of best focus as they are now. And then we're done. So now we can turn that off and get rid of that focal assistant. And I will turn on what I call temperature compensation. It allows us to compensate for the temperature. As the temperature changes out in the building, the focus changes with any instrument, and so we're compensating for that. As the temperature changes, the focus is going to shift back and forth. We have very, very, very elaborate focuser out there. It can actually basically measure in the thousandths of a turn. So we're of the focus knob, so to speak. So that really is a very effective focuser. So now if we go in here and maximize our view, this is I call this our enhanced or night vision view, our finder view. And so there's Spica. And again, this is a live image from space. These are all the stars around it. And if we can, let's just see if I can do like a 2-second exposure, and we'll stack it. And I'll explain what stacking is in a minute. But we're just going to do a 2-second exposure, and that 2-second exposure is going to give us an idea of how well it's going here. So let me just do this, match those colors up, and the stacks are always brighter. And what I'm going to do is bring my dark level down. Yeah, it's really bright. Alright. Okay, it's premature. It's too light out to do this. You've heard this song before. This is a famous song. Actually, there's several space games that actually use this. Pretty cool. Alright, so let me go down to 1 second. Bum, 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 bum. I love this song. You can see over my head the darkness is really encroaching in the building. That's good. We want dark, you know. Hello, Renee Cruz. How are you? Hello, Vera. Nice to see you. Martin Breed. I love it. Glad to see you, man. How are you doing?
Well, you were talking about donations to Sky Tour live stream and stuff a few minutes ago. And
yeah.
I really need to make a donation sometime. I feel like a freeloader here so often.
Oh, nonsense. You give out so much. You know what? You need to be paid, man. Don't say that. No. Don't even go there.
I know.
I do not expect and I will not accept a donation from you. You've earned your keep more than anyone else, let me tell you.
Well, I want to help.
Trust me. I know, and you are. You're here. That's help.
I know we've talked about plans for future telescopes there, and more focal length and such, and good grief, I have been looking at telescopes lately, and the prices on them have almost doubled recently. Wow. I guess with the inflation and everything.
Oh yeah.
Crazy.
Yeah, they're expensive.
That Celestron 9 1/4 I bought a couple of years ago. The tube assembly was about $1,000 when I bought it. Yeah. And it's $1,900 now.
Just for the tube. Yep. Hey, look, a satellite. Zing. Yeah. Now, in case you want to know what the music is in the description, all the songs are listed and credited because I don't want to have any problem. Let's see. Somebody asked me, and Martha, I'm sorry, I read you as Martin. I apologize. Martha says, "I'll be Martin Breed." No, you're Martha. I'm sorry. Okay, David Schmidt says, "Curious if they're using fuel as our physics allows us to understand that term. Then that means either they travel for a long time or they'd have to do faster than light travel." You know what, David? Actually, no. They actually sidestepped that entirely. I really should do my presentation for everybody here. Not now, but the concept is this. UFOs, if they're using this particular version of string theory that we understand, this version is called Randall-Sundrum 1. And in this, you have a brain. It's a membrane-based theory. And in the membrane world... Oh, another satellite. Ying. We're taking 1 second exposures. That's why they're dragged out 1 second at a time. In the membrane-based theory, our Earth brain, BRANE, is a membrane that consists of our X, our Y, and our Z, all moving through time. So our 4 dimensions are 4D. That's our membrane. But next to us is another zone called the bulk, BULK. And the bulk is a very special place. And next to that is another membrane called the Planck brain, PLANCK, Planck. All right. And at the Planck brain, the force of gravity is extremely high, 10 to the 16 times what it is here in our brain over here. And it drops exponentially as it gets to the border of our brain. And it goes through the bulk in the middle. Okay. Now, if you can accept that, then if UFOs use this technology to move around, what they do is they create particles that exist in this bulk area. And these particles are gravitons in this theory. They're called Kaluza-Klein gravitons, or KK gravitons. And we're waiting for it to get darker anyway, so this is fine. And these KK gravitons exist in that bulk space. They don't exist in our space, not for long anyway. And so if a UFO can generate them here in our space, then those KK gravitons actually drag the ship into the bulk a little bit. And the further in it goes, the more the space is warped. All right? It's a highly warped bulk, okay? Highly warped at the Planck brain at this side, and less warped at the brain where it reaches into ours. And so if you move into it any bit, what happens is time is slowed way down. Distances are shortened. So you could literally punch out of our 4D coordinate system, membrane, go into the bulk, and literally, once you're in the bulk, and this is a hard thing to swallow, but in the physics it works out, you're almost everywhere else at once. So you can go into the bulk and then pop out somewhere else. And I mean, there is real time it takes to do that, but that time, and I'm telling you all this because David Schmidt asked this question, that time is dependent on how far you have to actually move, okay, in the bulk to the next place. I'll give you an example. Alpha Centauri is 4.3 light years away. The fastest we can get there right now is about 10 to 12,000 years, okay? So at 10 to 12,000 years, we're not going to go there anytime soon, right? So what it means is that if we were to actually utilize a process where we actually use these membranes to travel, okay, then we might cut that trip down to the equivalent, and this is from a physicist, equivalent of about a 20-mile drive. Now that sounds fantastical, and it does. But it only sounds fantastical because we can't do it yet. But the physics is there. The physics is there in this Randall-Sundrum string theory variation with these three locations, our membrane, the bulk, and the Planck membrane. This looks like it constitutes the best way for us to get there. David says, but in the bulk, what is there that actually generates the gravity? Oh, okay, very good point. Okay, the gravity is generated. You're going to love this. The gravity is generated by the UFO. Why is that? Because they don't use anti-gravity to travel. You know what they use? They use mega gravity. They use massive gravity. And they actually, the particles to create this massive gravitational field, these KK gravitons, okay, when those are created, guess what else they create? They create micro black holes, which evaporate almost immediately. Okay, I know I'm going over a lot of heads right now, but understand that micro black holes are created when you have massive gravity, right, in a small confined location, right? So now you sheet your whole UFO with these micro black holes and with these KK gravitons, these Kaluza-Klein gravitons. What does that do when they're in our membrane? Well, first thing that happens is those micro black holes, which are replenished every split second or however long it takes to sheet your whole ship with them, those micro black holes are doing something very important. They're absorbing the earthly gravitons from our gravitational field. And what's that do? That doesn't allow gravity to get to the UFO. So it floats, it can hover, right? And because they're the Kaluza-Klein or the KK gravitons that exist in the bulk primarily, the ship gets dragged into the bulk the more KK gravitons you create. And if you create a whole bunch of them, in you go, and now the universe is your oyster, and you can go anywhere you want. See? So that's kind of the theory. And when the ship, now why would the ship generate these? How could it do it? Well, the reason it could do it is because the ships themselves are particle accelerators. That's right. Okay, UFOs, remember the saucer, the disc-shaped saucer? Why is it round? It's round because it's probably a particle accelerator. And when you have triangular ships, those triangular ships are also particle accelerators. They have a ring inside, probably. Now, there's one caveat. Anytime you have a forced path that goes in a circle, it means that you're bending with these guides, these light guides. You're bending the particles in a circular shape. Whenever you do that, perpendicular to the direction of the motion, you get something called synchrotron radiation. Synchrotron radiation is deadly. So one of the things that they would have had to come up with is a way with which you, a way in which you can actually control synchrotron radiation generation. You know, and so when you talk about this, obviously we don't have all the answers, and we don't even know if this is even a true way in which that we're seeing them operate. But take this for what it's worth. Every observed phenomenon, the flickering, the shimmering, the color changes, the fading out, the fading in, all of those changes, all the visual effects and visual phenomena observed with these UFOs is something explained by this transition into and out of the bulk space. That's pretty telling. That's pretty telling. Now, as an astronomer, and that's what I am, obviously you know that, there are many reasons why you can get color change. That could be atmospheric scintillation. There's many reasons why things can fade out or fade in. That could be limitations on the sensor. The sensor can't quite see to the degree you'd like it to. And maybe you're right at the verge of visibility for some of these things. Okay, maybe that's what's going on. But you also can say that these are Kaluza-Klein gravitons being generated by the ship, which is a particle accelerator, being sucked into the bulk. And it is negating, or not allowing, more appropriately, the gravitational force from our planet, the gravitons from our planet, from reaching the ship. Now, the other caveat, we haven't found gravitons yet. But then again, we weren't supposed to find gravitational waves either. Einstein didn't think we could find them, but we have. And when we look at light, we know that light, there's a satellite, that's actually a Starlink, most likely. Einstein thought maybe that we wouldn't see gravitational waves. But keep in mind that light, when you see light comes in waves, right? It's a wave, right? But it's also a photon. It acts like a particle, and it can actually be described as a particle. This particle nature of light and the wave nature of light is called a dual nature, right? It's a duality of light. Well, gravity has a wave form too. Does it have a particle form? Well, if the universe is anything, it teaches us that maybe, just maybe, it operates the same way as other phenomena. And why can't we see gravity properly? Why we can reflect light, bend it, do whatever we want. Why can't we do the same with gravity? Because maybe gravity isn't on our XYZ moving through time, our 4D membrane. Maybe it reaches out. In string theory, okay, where does that come from, the string theory? Well, everything in the universe vibrates, right, at a frequency. So, in effect, string is considered an infinitesimally small object, say a point that's vibrating back and forth. Okay, it's vibrating back and forth. As it goes back and forth, okay, that back and forth could be described as a path between the endpoints of its motion. And that endpoint path, okay, that could be the string, you see? So there's a definitive endpoint, this side, this side. Well, gravity is doing the same thing, but it's circular. It doesn't have an endpoint. So that means it can be vibrating anywhere, maybe outside of our dimensional space, which is precisely why we might not see it. Isn't that cool? And for you, those of you going, what? I'll explain further if you have questions. Just ask them in the chat. Vera, thank you. Thank you very much. Vera Lucia Campos, $20. That's so nice of you. Look at that. Starlink everywhere. So we're looking like we're pretty dark right now. So Daryl, sorry, I kind of went on there, so I apologize if you had wanted to say anything along the way there.
Yeah. Check your chat when you have a moment.
Okay.
You want to try that supernova now?
Sure. All right, thank you for letting me know. Let's go and find that supernova. We're going to go, it might actually be in our list, but we'll check it out. Okay, it looks like we're pretty dark here. It's not 4216, is it?
4647, I believe.
All right, let's see if we got that in here. We might have it. I can just write it. Oh, we got it. Look at that. Where'd it go? I just had it. Okay. Yeah, let me get it right here. NGC 4647. All right. And that's right there. Okay, let's go check it out. Now, for those that might remember, the supernova was pretty bright when we last saw it. Okay, off we go. You're going to see the telescope start to move. There it goes. Right there, watching it move. Stars are whipping around. We're heading up now here. We're going to go to a star that I call a waypoint star. And it's going to center it up in the middle of our view. Let me maximize our intensity here so we can actually watch what's going on. Here's the star being centered up. Normally it would tell us, but I forgot to turn on the indicator right there. But that star is going to be in here. Let me just look at it. See which star it is. Okay, it's in Virgo. It's one of the stars in Virgo. Okay, cool.
Yeah, it's pretty much up there in the Virgo cluster with all the other ones.
I believe this is the galaxy that had the supernova, not this one. I think we had two here, correct? Am I right?
I want to say it's the one dead center.
This one?
Yeah, there's bright one. It's M60, and NGC 4647, I believe, is the dim one just to its upper right.
Oh, this one here, you mean?
Yes.
Okay. Well, let's try a 20-second exposure here, guys, and see what we can find. All right. So we're gonna come out of this. We're gonna go right into a stack. All right. And what is stacking? Well, we take an image, right? And when we take an image, the image is taken, and then we take a second one, the same amount, and align the two together perfectly, line them all up, and just make an image sandwich of one after the other. And that allows the signal, the stuff we want to see, to come out. All right? And that's kind of what we're doing. So when we do this, we'll see the galaxies. Oh, look, the supernova is still there. And I'm going to now color correct, give us the right color, Yeah, look at that, Daryl. I think that's the supernova right there.
Uh-huh.
All right, let's zoom in on this, shall we? All right, let's go to 75%. Zoom in on this. It's going to be a little noisy right now because the stacking process gets rid of a lot of this mottled noise you see here. But there's the supernova right there.
Yeah, I think it looks brighter than it did last time we looked.
It also, if I don't miss my guess, it looks like it's not as blue.
This is true.
Yeah, it's not as blue. It's now distinctly orange. It wasn't orange last time. It was actually very blue.
Uh-huh.
So what we're noticing is a temperature change in the supernova. It's cooling as it's expanding. And so when it cools, the temperature goes from hot and blue down through white to yellow to orange to red. All right, in terms of the gas. All right. Let's go to 100% here. Make sure that I'm not telling you a lie. Okay, so let's go ahead and process this a little bit. Move our black level back a bit. There we go. Yeah. It's definitely orange. It was never orange. And this is color corrected. So this is a galaxy right here, guys. And this is a galaxy right here. This is... this galaxy, if I recall, this was further away from M60, wasn't it? I think it was.
I forget.
Okay. And I'm going to label this as NGC 4647 Galaxy, GAL, and then SN, Supernova. All right. Okay.
No, it is considered to be interacting with Messier 60.
I sort of remember that now.
Yeah. It's an ARP object, ARP 116.
Okay, that's why it wasn't showing up properly. All right. Okay.
Tidal interactions between the two have just begun. A Hubble image taken in 2012 shows that.
Okay. All right. That's cool. So let's...
And they are, of course, members of the Virgo cluster.
Yeah.
And that reminds me of something I think it was Donald Kunzer asked on the last stream.
Okay.
Why aren't the M objects sequential? And I don't know if I misspoke or it was just more complicated. If not sequential, well, just the Virgo cluster is so rich. And Messier and Pierre Michel and other contributors to the Messier list spent so much time in the Virgo cluster because it's so rich. If they're not sequential, they're darn close to it. That you like, this is M60, the one to the lower left, Messier 60, and you will see a lot of Messier galaxies in the Virgo cluster that are all, if not sequential, they're really close to it. You know, like in the 60s and the 70s and the 80s and 90s and stuff like that.
Yep. I'm going to pull us back a little from the black level just to lighten the background a little bit. And then I'm going to soften the noise a little bit just to make it look a little better. Very, very, very different look from before.
Yes.
That's really, really orange, and it was not orange. So clearly the temperature is dropping in the supernova.
Yeah.
So this is what this shows, guys, is that, you know, the universe is changing all around us. And this is proof. This is proof. These dots, these bright spots are areas where the pixels happen to be erroneous on this particular exposure. And they could work the next exposure, and, you know, it varies. There's random ones every time. But the fact that they're almost dots shows that the guiding is actually quite good right now. When they're lines, it means that the guiding is having trouble. But right now, it's looking pretty good.
I'm going to go try to find earlier images on the your server.
Okay. They're out there. They're labeled.
Yeah, I'll be right back.
Okay. Well, we stacked 17, so we made an image sandwich of 17, which is why they look so much nicer right now. Because initially they would look quite noisy, but now they look better. I'm going to try to... If I pull it back, you can see some of the noise still remaining in the image. Okay, see that modeling? That's kind of noise. But what I'm going to do is I'm going to pull us back off this black. This here is the entire peak of the data. You can see it. And if I pull us back to the left a little bit, we're going to have more stuff in the background. Okay, so there you see it. And I'm always color correcting because with each exposure the color can be off a little bit. The idea is that you want the red, green, and the blue curves that you see over here to align with each other as best as possible. Okay. This is additional noise out here that you're seeing. This is not usable stuff, so not to worry. All right. Wow, this looks really pretty. I'm amazed at how this has changed. This is really, really different. So what do you think, guys? Is this pretty cool or what? I think it looks really cool. That's a... and then supernova can be like this for weeks or months, you know. It depends. And keep in mind that this supernova is occurring in this galaxy. And it just happens that we have sort of a ringside seat to it, in a sense, because we can see it.
Okay, I found it.
Okay.
Looks like it was more. April 30th. The one image I found.
Yeah.
Kind of black and white. Whoops.
It might not be a processed image too. That's the other thing. It's only processed raw. I probably didn't do any. Probably didn't re-upload.
Okay.
There we go. There we go. Every smudgy spot is a galaxy. The whole island universe. All its own. It's a little early in the process for the supernova, but we might be seeing the beginnings of a stellar remnant here. Not sure.
Yeah, I can post one of these if you like. They all look about the same. They don't really show color. The supernova was quite bright back then too. April 30th.
Yeah, it was saturating. It was saturating the detector, but it did look blue when we brought down the brightness. Like when I went and I did, I'll show you what I did when I actually did this to reduce the brightness in the center of it. I brought this down. Okay.
Okay.
Okay. See, this is distinctly orange right here.
Oh yeah.
When I did that with those other ones, it was distinctly blue.
Yes.
And so that is the difference, and that's the thing that we're seeing now. Now, there's a law in astronomy called Wien's law, W-E-I-N-S, and Wien's law tells you the color to expect for a certain temperature. So for a certain temperature, you get a certain color. It has to do with black body radiation. Don't worry about that. It's just the way things radiate, like the way stars radiate energy in space. Well, in this particular case, this would indicate a temperature somewhere around 3,500 Kelvin if it was truly orange. And that's a possibility, but we could also be seeing something else there. But I just think it's pretty cool. I'm really enjoying this.
Yeah, it's a great change in color.
Yeah. Is this, hey, Judy McClelland. Well, actually, Judy, this is the supernova. This is a star that already exploded right here. And that star used to be a little more blue when we first started looking at it. And now it looks distinctly orange, showing that it's cooling a little bit. And eventually, it'll drop to a brightness where we can't even see it anymore.
Yeah.
So that's pretty cool. And for those wondering why I'm looking over here and looking over here, this is my broadcast side where I have all the chat and everything, and this is the actual observatory feed right here. So that's what Daryl's looking at. I'm looking at the broadcast feed with chat comments and volumes and other stuff as well on this side. I've got several monitors that I'm monitoring here. Boy, that's really pretty. Now we've done, this is 33 stacked. What I'm going to do is I'm going to save this stack right here. So we'll pause it. We just did 34. That's good. I'll pause. I'll save. And now we're going to save the raw file. When I hit save, you're going to see a green bar across the top. There it is. It's saving in an astronomical FITS file format. There's free readers online to look at that. But you don't have to, because I also am going to save it exactly as you see it here. Right? And that's what this will be right here. Save exactly as seen, and then you'll see the ping file labeled there.
When you see that star supernova there in NGC 4647, looking back at the earlier image, it may have been brighter then. It was bluer, which is a sign of greater energy, but the brightness of that star is comparable, if not as brighter than all the rest of the stars in that galaxy. Billions of stars.
Yeah.
It is that bright.
Yeah. Novas are certainly that, and this is just a regular supernova. There are certainly supernovae that are even more bright than these kind of supernovas, and one of them is called a kilonova. Another is called a hypernova. And so those are really, really spectacular.
This was thought to be a Type 1A supernova, wasn't it?
I believe this was a Type 1A. A Type 1A is a supernova where you have a binary star system, and one of the stars evolves to a red giant and then shrinks down to a white dwarf. Now, white dwarfs can only be a certain mass. If you add mass to them, then they can catastrophically destroy themselves and blow up. And that's precisely what happened, because there is a companion star that was also orbiting it. So these two stars were orbiting each other. One of them turned into a red giant and then shrunk down to a white dwarf. And then the other one turned into a red giant. And as it did so, it started feeding gas to the white dwarf. And now that gas was going onto the surface of the white dwarf. And the white dwarf was mostly carbon and oxygen atoms on the surface of the white dwarf. And now it's feeding hydrogen and maybe some helium onto the surface of this white dwarf, adding to the mass. And the white dwarf was already at approaching a critical mass of 1.44 solar masses. That's called the Chandrasekhar limit. And once it reached that limit, then the star would go through another process, and that is where enough gas accumulates on the surface of the white dwarf that it would go into what's called runaway fusion of that gas on the surface of the white dwarf, because the white dwarf isn't doing any kind of fusion anymore. It's just basically a hot remnant of a stellar core that's cooling. And alone, if it left alone like our sun is alone, then that would take several billion years to cool off, many billions of years actually. And but in a pair like this, then that star could absorb a lot of gas from the other one that was feeding it. And once it reached above 1.44 solar masses, runaway fusion could begin, and the star could either continue to collapse or will be blown up. And that explosion is called a type 1a supernova when you have that as a binary, okay, a binary activity. And the type 1a supernova is what's called a standard candle, because that means we can measure it. We know its distance because we know how bright they are. And so looking at the apparent brightness here, that's not the actual brightness, what we call the intrinsic brightness. The intrinsic brightness is something we know based on understanding type 1a supernova. So knowing the apparent brightness, how it appears on the camera, on the image, and the intrinsic brightness, how it would appear at a certain distance that we consider a standard distance that we set up. Those two brightnesses can give us the distance to this object. It's called the distance modulus. It's basically the difference in the brightness between the apparent and the intrinsic brightness of an object. It's a really cool thing to do, and it's kind of fun to do it when you find out the answers. You know? So, hi Dagger Spells, what's happening? Alright, so we are done with this object. So I'm going to clear it, and let's move on. It's dark enough now, we can go have some fun with some other objects. So let's do that. Our telescope, as you can see, is looking almost straight up. So let's bring back our control panel there. There we go. And let's go look for something else. Coma Berenices. Coma Berenices. Is a wonderful place. This is a wonderful, wonderful constellation. It's full of really good things, including Measure 53. Why don't we go there first? Sure. What do you say? Okay. And we're going to go there now. Measure 53 is a globular cluster, as Daryl just said. It's a cluster of many, many stars together. And I got to change our exposure back to 1 second here so we can actually see what's happening, because otherwise we won't. Okay. And then we can... There we go. And now it's centering up the star Vindimiatrix right here. It says so right there above me. See that? Vindimiatrix. You don't see the X on the end of that. And we're at 150% on our sensor right now, so we're zoomed. This the native size in our sensor is this 100%. Okay, there's the cluster. But let's fill this screen, and here is the scaled size to fit the screen. So it's literally 4 full moons across and 3 full moons tall. So that's pretty cool. Pretty cool, pretty elaborate. Alright, so now what we'll do is I'm just gonna center it up a little bit. Why not? Don't have to, but why not? That's gonna move us a little bit west. Okay, and a little bit south. Center us up. No reason, I just want to. Okay. Alright, now what we'll do is we'll take a 25-second shot of this cluster. Right there. And then we'll come off of our hyper view, as I call it. The finder view. You can see down here, this is the yellow bar down there is progressing. That's the shot as it's being progressing. And then I'm going to come in here after taking off that hyper view, go into our stack so we can see a proper rendering of this globular cluster when it comes in. And we are guiding. You can see by the numbers changing right there. And there's the cluster. But let's try to bring that cluster out a little bit. And here we go. All right. And you say, well, wait, it's not red. That's correct. I'm going to color balance now. Watch the curves. Watch where the red curve goes. There's the green curve and the blue curve. We want those to kind of line up with each other. So here's what we do. We're going to color correct. All right. And there they are. See, now they're lined up with each other. And when they're lined up with each other, we see it the way it should look. And it's actually too bright. It's like too long of an exposure. We have another cluster right here. That's pretty. Okay, and a bright star right there. So let's go down and grab our live stack again right here. And let's go mess with our settings here. Let's drag this down a little bit. Okay, just to see something really interesting. Okay, that's cool. And I'll bring this over. By the way, folks, as summer approaches, it's going to be another summer of beautiful dark nebula and gorgeous star forming regions. Lots of wonderful nebulae to look at. When we look in the sky, in the spring sky like this, what we're actually watching is we're actually seeing nebulae, but they happen to be millions of light years away in other galaxies, which is cool. All right, let's zoom in and check everything, see how we're looking. I'm going to go right to 100% now. All right, and there you go. Look at that beautiful, gorgeous sphere of stars. Isn't that beautiful? Yeah. And this is M53, M53. And I put the indication that it's a GC, a globular cluster, after it. That's pretty, huh, Daryl? Are you there? Are you on mute?
I'm sorry. Yes, I was muted.
Okay, no worries.
I was sneezing my head off.
I'm glad you put it back on.
Yeah. If you zoom back out, it looked like there was an interesting open cluster down to its lower left.
Yeah, I mentioned that earlier. I'm not sure what cluster that is. I'll have to check it out. There it is.
Yeah.
It's pretty faint. Let's see if we know what it is already. Let's go into our planetarium setup here and see if we can identify that cluster. Okay. Let's zoom in a lot more here. First of all, let's center up here. Oh, apparently that's another globular cluster. Look at that. It's NGC 5053.
Pretty faint for a globular.
Yeah, it's CR267. That's its designation too. M53 we have here. Yeah, let's see whether. Yeah, we're centered here. So, what I need to do is I need to tell the telescope that this is where it should be. So this should be moving now to the center here. There it goes. All right, so now our telescope coordinates have been reset, properly synchronized. Yeah, that's an interesting. Oh, by the way, this red square, guys, is the field of view. So we have the cluster here, we have that one down there, and we come back to our view. All right, and we have the. Let me actually zoom out so you can see it. Let's go to our auto-fill, to go to the screen extents here. Okay, so there we go. And you can see the cluster and the other one down here. And then that star should also be in our view. So if we come back to here, to our planetarium, the star should be down to the lower right. And it is. It is Diadem. It's this star right here. All right. So NGC 5053 is a cluster that is literally, you ready for this? It's 56,700 light years away. It's a very distant cluster. What is this one? Let's go find out. I gotta probably, okay. This one is 58,716 light years away. So that means that this cluster is actually, well, I don't know why it's so dim comparatively. They're about the same distance. So it could either have fewer stars or whatever, but it's actually kind of cool.
I looked it up. It's a globular, but it's very sparse by comparison to M53. You couldn't zoom in on that, could you?
Yes, I could. It's to the lower left, though, but we can try it. I mean, we won't be able to do it, but let's find out. Let's go down here. Yeah, it is pretty Spartan, isn't it?
Yeah.
Oh, I see a core. I see a core. Interesting. The stars aren't perfectly round down there, but that is only an optical effect. Okay, that's really pretty. Okay, this is 10 stacked images. That's good for now. So we're gonna go back here and we're going to pause this here. I've got it labeled properly. We're gonna save it. And we will see the notification across the top, and then we will save it exactly as seen. Here we go. And then we will clear this, come out, and move to the next object. Oh, for bids, and the price is right. Yeah. Okay. Okay, 1 second. That's our time, and then let's do our finder mode, our hybrid mode. All right, cool. Now we come back to our planetarium here. There goes another Starlink satellite, probably. When they go at these diagonals, that's pretty much how Starlink is going through our fields. So that's why I'm calling them Starlinks. I'm guessing that's probably what they are. Alright, what do we got now? Well, I know that we have in Coma Berenices, we have some beautiful galaxies up here. Let's check
Marc,
those out.
Can I make a suggestion?
Yeah. Sure.
Our Kunzer needs a wrench.
Oh. Well, I don't know why he didn't have one.
It's a solemn responsibility, Donald.
Yes. Well, Donald, you're now a moderator. In fact, many of the people that join us, I will make you moderators over time as we go. Okay. Because you deserve it. You're here every time. You should have some privileges. Okay. This guy here. NGC 4725. Yeah, this is a nice barred spiral. Why don't we check that out? There we go. Over there. Alright. We're gonna check out this barred spiral. The galaxy classification scheme is a little bit different from the way Hubble envisioned it. It's the De Vaucouleurs system now. The Hubble tuning fork diagram had spirals and barred spirals. Spirals that had this extended nucleus in the middle. Okay, that extended nucleus would lead to spiral arms that come out on each side of those ends of those spiral arms. And so these would be, you'd have spirals over the top, they're just these nice smooth spirals, and then you'd have these barred spirals at the bottom. But the De Vaucouleurs system recognizes hybrids between the two. So this one is one of those hybrids. It's called an SAB, capital B for barred spiral. So it's a tightly wound spiral that also has a bar in its nucleus. Okay, and this is it right here. So let's actually, I can actually just move it over right here. Let's move it over. All right, there we go. And now let's try a 35-second shot. All right, there we go. 35 seconds. And our progress bar starts up over here, as you can see. And we'll get out of our hybrid view, go into our stack. Yep. And Marianne, hey Marianne, Rob, how are you doing? That's okay, Marianne. Marianne says she can't stay very long. That's okay. Thank you, Bonnie. This is a beautiful song. It's called Melody of Nature, by the way. Melody of Nature is the name of the song. As I said to you, all the music is new. Oh, this is a beautiful Bart Sparrow. You cannot miss the bar. Let me just do a color correction first. Yep, and then let's try to pull out a little data. Okay, this will be a little too noisy at the moment, but we've only stacked one of them. We have another one here, another one here. But this is what I mean by a barred spiral. You notice how you've got this bar through the center here, and then the spiral arms seem to come off of it. It kind of looks like a steering wheel. I think Daryl mentioned that, actually. You said that the other day as well.
Yeah,
this
sometimes they really do. It's almost like there's a complete ring inside, and the bar makes the spokes on the steering wheel.
Yeah, this is NGC 4725. That's the designation, and NGC 4725 is a new general catalog designation. There's like almost 8,000 of these things, I think, right? In terms of the catalog. I don't remember the exact count. I think it's around 8,000. Okay, this is a...
How many NGC objects?
SAB. Somewhere around 8,000, I thought.
Something like that. 7,800 or something close to that. Mark, I don't want to take away from what you're doing. When we leave here, though, don't let me forget, I wanted to see something that was just a little north of this in the sky. You may have even marked on it. I missed it at the time.
Sure, what would you like to see?
Well, let's wait till we're done here.
Oh, I will, but that's fine. Okay, I'm gonna bring our dark level over just a bit to try and clip off some of that noise in the background that we're seeing, just to darken it up. It'll increase the contrast between the arms of this galaxy. There we go. All right, and we'll color correct one more time, get rid of that subtle green color. Yeah, okay. So now...
Actually, quite a bit going on there.
I know. I'm going to zoom in now. If you look where the telescope's pointing, okay, the telescope's pointing almost directly overhead. So we should literally have quite a view here.
I see a large dark gap to its lower left, and
one here too.
A faint spiral arm.
Right there.
That right there.
Yeah.
A very faint spiral arm
all the way around.
To its left that goes much of the way around it.
Yeah, like right there.
So what happened?
That's why I wanted to do a. That's why I wanted to do a 35-second exposure, because there was so much going on here.
Oh.
Let me first bring this up a little bit. There we go. Look at that, huh? And while we're at it, why don't we just pull that in, man? Come on. There we go. Alright, we have another galaxy here, which is really cool. Let's go into our stack, and let's see if we can bring out some more detail in here.
What's the number on this?
This is 4725.
4725?
Yes. Yes, indeed. I'll soften some of the noise here. A little more. I hope you guys don't mind the dynamic processing I'm doing. Now, you'll notice that these stars here, these are all in our galaxy, so they're all up here. Okay, the galaxy is way back here, way, millions of light years beyond. So we're seeing foreground stars and seeing through them. And each of these dots might be foreground stars. We'd have to look to make sure that those aren't massive nebulas in these galaxies, because we do see that too. Wow, this is really clear.
4725 is the brightest member of the Coma 1 group of the Coma Sculptor Cloud. Galaxy is strongly disturbed and is interacting with a neighboring spiral galaxy, NGC 4747, with its spiral arms showing indications of warping.
Okay, let's go see if that's the one. So we're going to come back here and come back into the field. Is that the galaxy right there? Yeah, that's 4712. That's not 4741. So let's see if that's the one.
4747.
Alright, so where's 4741?
Where'd you get 4741?
You just said that, I thought.
No, 4747.
Oh, so it's interacting with this galaxy here.
Okay.
Okay, so let's...
4725 is the Sapert galaxy.
Yeah.
Got a supermassive black hole in its middle.
Yeah.
And has a distinct ring.
Very much so. You can see it. And you can see these blue stars here. Right here especially, you can see this real intense area of hot blue star formation that took place in here. And that's where stars are formed. There's in the spiral arms typically, guys. So you'll see them there. And these spiral arms are disturbed. You can see there's really an extensive tugging that occurred over here. And apparently this galaxy, I know it doesn't seem possible, but you have to understand that these are actually interacting with each other. They could be orbiting each other as well, or have orbited each other already. And as they pass near each other, they would pull off gas and stretch them out, and then we see this snapshot in time right there. That's a snapshot in time. That's really pretty.
It is.
Look how beautiful that is.
Yes.
We're actually at the actual scale. This is the 1-to-1 scale for our sensor. So this is 100%. So this is how big it is. So we have tons more off the frame in every direction. So if we were to actually fit the sensor to the frame, it looks like this right here. Okay, and so does that satellite. So that's the size of our sensor. Again, 4 full moons across, 3 full moons tall. 2 satellites came through at some previous time, and these satellites are transients. They appear on just one frame, perhaps several, but over time the background, which is the starry black sky or the stars themselves, will tend to dim those down, and they'll go away over time. So this is the galaxy right here that this galaxy is interacting with. This is 4747, and this is 4725. So that's really pretty. That is just beautiful. And the picture is really stunning. It's actually coming out very nice. So this is 100% right here.
Yeah.
Let me get down to...
Says it's actually
100%.
It has a double bar, whatever that means, and the ring is noticeably offset from the center of the galaxy.
So I see this coming off here.
Yeah. And that dark thing down at around 9 o'clock to 6 o'clock or more. No, farther out. That real dark area. Yes.
Yeah.
That's real also.
That is real, yeah. Okay, let's do this. Let's again, I'll move it up. I'm gonna do what's called push. I'm going to push the processing. I'm going to actually try to pull out more detail. It's going to make it look a little bit less good. But this is something that we do to try and pull out more detail. So we're going to push this. Okay. So you can see this hazy exterior area here. It kind of goes around. And this dark area here does not exist on the other side. So clearly there's an interaction that's taking place here.
Yeah. There at about 10 or 11 o'clock, there was a sharp kink in that inner spiral arm.
Right there, right there.
Uh-huh. And then over at the lower right, there's a kind of a curved blue band about 180 degrees from the one that's upper left.
Not
that
this
right
one,
there?
right?
Yes.
Oh yeah, well, I was mentioning that. I was pointing that out as a bunch of blue hot stars, probably O and B stars that are in this galaxy. Again, some up here as well. And these bigger dots you see here, these are probably in our foreground up here, and the galaxy's millions of light years beyond. We're seeing it through the veil of our own stars. Okay, so that looks to me like that's pretty good. So I'm going to give this a processing view one more time. That's really pretty. Okay. This is 17 stacked. We're going to let this last one come in, go to 18, and we'll pause it and move on. Okay, we're at 18 stacked now. We're going to pause this, save it. This is the raw file that we process further, and then we save it exactly as seen, which is the in progress processing that we do. All right, so there we go, and that's going to be under 4725. It's an SAB Galaxy. All right,
good.
so now we can clear this. And
I think I found
get
the
rid of
answer
this.
to what I was wondering a minute ago.
Okay.
Can you go back to Stellarium for just a second?
Yeah, just a sec.
Whenever you're ready.
Yeah. Okay, so 1 second here. Let me, first of all, let's push this up so I can see my telescope. All right. I want to get to the telescope again. Okay. And now back to Stellarium.
And scroll out a little bit.
Okay.
A little
Black
more.
Eye Galaxies right down below.
Okay, maybe we can go there. But
Yeah.
there was one thing, there was a caption up above it I wanted to see.
Oh, what was it?
It said something like Polaris Galactic something or other Borealis.
Oh, right here.
Yeah, that's the Galactic North Pole right there. The article
Yeah,
on
Polaris
4725.
Galacticus Borealis.
Yep, that's the Galactic North Pole right there. The article on 4725 mentioned that.
Okay, very cool.
Okay.
All right, let's go to the Black Eye Galaxy and let's have some fun with that. The Black Eye Galaxy is right here.
Yeah.
And I'll let it find it. We could just steer to it, but you know what? In the interest of time, let it just find it. Okay. So off it goes. It should find it in a second here. I gotta... Apparently I didn't tell it to go.
Whoops. Would you excuse me just a moment, please?
Yeah, go ahead.
Thank you.
Let's go back to 100% to auto. There we go. That's what I thought. Yeah, it wasn't 1 second. We were screwed up there. Okay. Now we'll see what we're looking for. Alright. And pull this in. And we should see the black eye right there. Oh, this galaxy gave me a black eye. Donald Kunzer asked, is the receiving element making that grid pattern? You mean that little squares? That's actually the sensor layout, yeah. So what we're going to do is we're going to move over a little bit to the west. And center it up. All right. Go south a little bit. There we go. That's good. All right. Okay. Now we have to let our guider system find a star. And after, well, trying to find a star, what I'm going to do is I will... Yeah, all right, it's already started. So I'm going to set us for a 30-second exposure. And come out of our hyper mode and go into our stack. All right. And that's our previous one. So you can see that galaxy, but that's a single frame. So you see how noisy that looks? The stacking cleared a lot of that up. So let's clear this, wipe this out. Okay. And that leaves us the ability to pull in our new one. There we go. Stack has been cleared. And here comes the Black Eye Galaxy. Look at that. Oh yeah. The Black Eye Galaxy is really interesting because it has this amazing central area that has this little black eye patch on it. It's really cool. Let's go to 75%. It's a little noisy, but you'll watch it clear up. All right. Here we go. All right. So, see with each success see we just saw a stack come in. That's why suddenly a lot of that noise went away. All right. Let's color correct. And we should be fine. And Daryl's back.
Yep.
And now let's let me just get this fixed here. Move us over here. Drop that down a little bit. There we go. See the beautiful details in this outside edge of the galaxy now.
I'd rather fight than switch.
Yeah, you say that every time, but I remember that ad. Daryl was referring to an ad for cigarettes that used to be on TV, if you can believe that.
Territon brand, wasn't it?
Yes, it was. My parents used to smoke those cigarettes, and I couldn't stand it.
Uh-huh.
Yeah. Sometimes they'd ask me to go get them a pack of cigarettes, and I would never do it. I absolutely refused. I'm such a rotten son, huh? There we go. Look at the detail in here, guys. That's really pretty, and it's going to just get better. I mean, we have only stacked 4 images, and once we get up to around 10 or 12, then we start to see more detail here. The brighter parts of an image will resolve into more detail faster than blank space, okay? If you notice, guiding these green dots and the little dots, the errant pixels, you want little dots because it shows you that the guiding is going very well. In other words, the telescope's not moving much. And if it does move, I mean, it's keeping the stars aligned, all right, but it's showing you that the telescope doesn't have to work very hard to guide right now. That's nice. So this is that dark galactic dust. We have this dust in our galaxy as well. And you can see more detail out here. This galaxy has a strange little variation in its outer arm here, known as the Black Eye Galaxy, for this dark brown patch, which is very prominent. God, that's beautiful.
It is.
Okay, we're up to 7 images now. Okay. Let's see if I can help us with a little more of the detail now. Pull down the black. Give us a little more visibility. And let's pull this mid-level in some to try and increase the range. Oh yeah, look at that. You just have to see some details now appearing in here. Really nice. This song is called Discovery, by the way, by Scott Buckley. It's a good song for hunting through galaxies.
Too bad you can't play Jean-Michel Jarre. That's some great space music.
Well, you can license music to play, but you got to pay for it.
Yeah.
You know,
you might remember back in the days of Carl Sagan's original Cosmos, they used
oh yeah,
snatches of his Equinox and Oxygen albums.
yeah. Dun, 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 dun. Oxygen. Right, that was the Oxygen one. Okay, let's get out of this screen, and let's go to the full majesty. Pull this over. There we go. Center right up. There we go. Welcome to the Black Eye Galaxy, guys. Okay. Oh, yeah.
Someone
Really
pointed
nice.
out a while ago, we're only 3 weeks away from the beginning of summer.
Yep.
And we'll be able to see at least some of the galaxies still for a while, but
Yeah.
it's getting to be time to head for the Milky Way.
Yeah, we will. Michael Klaga says, is C-34 high enough to see yet? Caldwell 34? I'm not sure, Michael. We're going to find out. While we're doing our last shot here. We're doing our last stacks here. Why don't we go in and look for Caldwell 34 and see where it is. Caldwell 34. And let's go see where it is. Yeah, it's on its way up, but not yet. That's like the veil. So it's just rising.
Oh.
Witch's broom.
Yeah.
It's up, but it's not in a position where we can actually watch and look at it. But good thought. It's amazing. We're going to be back to those in just a short time. It's up in the northeast, just rising now.
Yeah.
Just rising now. Yeah. That's funny. In the east, the Eagle Nebula is already up.
Uh-huh.
Yeah.
Too low, probably.
Oh, very much so.
Yeah.
It's below 10 degrees. It's like, is it 8 degrees up? 6. So it's actually pretty low.
I saw a
That's
painting today of a portion of the Eagle Nebula. I don't remember ever hearing it before. It's called The Fairy in the Eagle. Have you ever seen that?
No. I have not. I haven't. Okay, so this is where we are.
Fantasy asked earlier about if we could see M87. I know we looked at it last stream we did.
Okay. Well, when we're done with the black eye here, let's see where M87 is. We'll find out right now.
Sure thing, Fantasy. Yeah, it actually, there we go.
Yeah.
The Virgo Galaxy.
Yeah, I mean, if we're gonna go to it, we should go to it and just check it out. But let me come back here. Now that we have 22 stacked, let me show you how it can be improved, how much it'll improve. Check this out. We're gonna just pull down a little bit of this detail and look at how gorgeous this galaxy is gonna look when we actually work on it. Let me actually do this, do another process on it just to kind of squeeze a little more out, and then I will pull it back a little bit. Pull back this is called this is the mid-level, or you know, the middle brightness range. Way over here on the right is the white level. You know, we don't want to play with that too much. But we are at 23 stacked, so this is almost done. I'll let this go to 24. Notice the dots. Those dots show that the guiding needed very little to do. Okay. All right. So we have 24 stacked. We'll pause it. I've got it labeled up there, so we're gonna save it. And there is our raw saved right across there, the fits. And now we're gonna save this exactly as seen, so you can have this just like this to put on all your wallpaper, anything you'd like to do. And these are all free. There's no charge to use our imagery. I don't charge you at all. Okay. All right, here we go. The only time I charge is if people want up-res imagery, and I can actually take those and up-res them so they can fit in a billboard, you know. But no problem. All right. So let's go back to 1 second here.
It was actually 3 years ago, Fantasy. 2019. Time flies.
What did Fantasy ask?
Oh, he said he forgot to mention M87's a black hole. It was the first image.
Oh,
Black hole. Yep, that was
Yeah.
2019.
that's right. All right, let's go and pre-fill. Let's do the auto size to fill our frame with the entire frame of the camera. Fill our image, I should say, their image view. All right, there we go. Got my telescope back. Hi, telescope. And we can bring our computer back online here. Boom. Okay. Now, let's go back here and check out M87, which is kind of neat. And tonight, it's well placed to actually see if we can find the jet in this. And the thing is, the jet is a feature. It's a radio jet and a visual jet. It's a jet of material being shot out by the black hole that we imaged, actually, that astronomers imaged. And that image is interesting because the jet itself is somewhat faint, but the galaxy is bright. So to image the jet is tough because to capture the jet, you got to expose long enough, but then the galaxy overwhelms it with its brightness. So we have to kind of do a in between thing, which we're going to do. Oh, M42 and M43 is your home wallpaper. Fantastic, Fantasy. That's cool. I love it. You guys are welcome to them. Aquila is not visible yet, Cindy, but it's good to see you, by the way. Tom Jensen, hey, how are you doing? Aquila is a summer constellation. It's not up yet. I shouldn't say that. It's sort of up now, but it's way in the northeast and well below the level of the walls of the building right now. And when you're looking down that low, you're not going to see much anyway. Yeah. Yeah, Jean-Michel Jarre, Vangelis, and Steve Roach, yes. All right. Let's go and pull this over.
Did you know that Jarre gave the highest attended concerts ever?
I did not.
He did.
Wow.
Like 1 million people or something. I forget.
How could 1 million people ever fit in a concert hall?
It wasn't a concert hall. It was open air.
Oh, okay. It's like a Woodstock thing.
Yeah, I'd have to look it up.
But not Woodstock. We're going to do 25 seconds here.
Broke the record a couple of times.
Okay, 25 seconds. We're going to live stack M87. And then we're going to zoom in and show what's going on up there in M87. Right up there. Right there, right there, right there. Okay. Okay, there's M87. You see some galaxies off to the side. We're in a very bright galactic region. Alright. We're going to go right to 100% because we're going to be searching for the jet. It's elusive. But with the telescope pointing where it is, we might have half a shot here.
1979.
We also had... Yeah?
I'm sorry. 1979, Jarre performed to a record-breaking audience of more than 1 million people at the Place de la Concorde, a record he has since broken 3 times.
Wow. Very cool.
He big outdoor events were his thing.
Yeah. Is he still around?
Yeah.
Well, how old is he now?
73.
Okay. I've zoomed in on M87 right now. Oh, there's the jet right there. Look at that. You can see it. Very clear. Very nice. Okay. And if we let that come in more, it'll show us. Now, it's an elliptical galaxy, so that's about the best you're going to get it. So that's pretty interesting. Let's zoom in even more. Yeah, you can see the jet right there. Look at that.
Oh.
Can't miss it. Man, it's sticking right off there. In fact, I bet you we can refine it even more. Come here, you. Bet you we can refine it even more by doing this right here. We're going to drag it down a little more. Isolate it a little bit. And there'll be a point of no return where it doesn't get any better. But you clearly see this sticking off here. That's pretty cool, huh?
Mm-hmm.
All right, so let's bring that back now to about here. See how the brightness of the galaxy hides it? But right about here is where we start to see it. And then as we reduce this brightness even more, it literally leaps out at you right here. That's nice. And I also see that we probably should refocus.
I knew you were going to say that.
I bet you did.
Yeah. Gosh, you're pushing it at what? 450%?
Yeah. Yeah. But, you know, I mean, the faint stars show a little bit of an autofocus situation. So I'm going to clear this. And I'm going to get rid of it. And I'm going to go into our system here. Set us to 1 second again. Okay. And get out of this. And come back to... Didn't mean to do that, sorry. And we'll set this back to our auto frame fill. There we go. Alright. And let's do this now. Let's pull this in. There we go. Alright. Let's do our focus system here. And I'm going to zoom in a little bit. Go to 50%. It sees the whole frame regardless, but this will be more visual. Okay, so now we're going to go in and do our refocusing. And it'll pick stars to focus on, which will make it better. So, focus assistant. I'm still waiting for us to have our Starlink, which is out there, hooked in. Still waiting for that. It's there, but it has to be hooked in. Okay, we're going to scan in now. And it'll focus and make our curve again. This is actually a very nice technique for focusing. And the reason it went out of focus at all is because the temperature changed enough that our temperature coefficients are not fully refined enough yet. We got some more to do. But look, it's, you know, in the professional world, critical focus is done for every shot, sometimes multiple times. And we actually do it kind of along the way. All right, we're at 7 of 12. as opposed to 7 of 9. So we can see our curve here is going back up. And there we go, right there. That's our point of best focus. So once it finishes all 12 steps, it will make our curve, and I can then tell to go to the best point in that curve, and you'll watch it all get nice and clear. All right, here we go. So all the way across, and then all the way back to that center point. There we go, coming back. All right, we are all focused now. All right, that's good. All right, yeah, this is fun tonight. This is a fun night. All right. Now we're gonna just zoom in again. Let's go to 100%. Yeah, I would say that looks a little better. Let's go to 450 again and see what it looks like. I'll go to 400. Oh yeah. Now see, those definitely look like the right stars. There we go. Okay. Nice. And I'll put the temperature compensation back on. And we're good. Alright. Alright, let's see now. Where else to go? There's so many places to go. Remember the Lost Galaxy of Copeland we saw that one time?
I do.
We should go there unless you got one you want to go to.
No, that sounds great.
Yeah, this was beautiful. This was a gorgeous pinwheel galaxy, if I recall. And we'll tell to go to this region rather than to a specific object. So, here we go.
I remember there were 2 lost galaxies there.
Yeah.
And it turned out Copeland was a poet, and seeing the galaxy made him wax poetic, and he kind of took liberties with it. It wasn't really lost.
Yeah.
He was an amateur astronomer.
Yeah. This is Alva. We're going to the star Alva. Well, amateur astronomers have their place too. After all professional astronomers were amateurs at one point or another.
Yeah.
And the only thing that defines them being professional is that they got paid for it. Okay, there we go. We got one here, we got one there. Let me come back here and check our view. So we're actually in this. I went to a region rather than to a specific object, but I don't mind doing this and saying center on where the telescope is, right there. All right. So if we center on that, we should see the Lost Galaxy and the Lost Galaxy of Copeland. We should see 2 of them just to the right of center. And we got one right there, and we got one right there, just like that. Okay.
You got one over at the right-hand edge, too.
Yeah, I do. I see that.
I think that's it, M49.
Yeah. And let's do a 40-second shot of this and see how that looks. So 40 seconds underway. You can see by our progress bar over here, and then we're going to go into the live stack. And with the live stack, we may have to clear the previous one. And we do not. We did it before, so we're all set. That's good. But what I'd like to do is I always like to make sure that we have the curves fitted first, make sure that the proper processing is done initially, and that the right colors have been recorded. The data is all there. It's just a matter of fixing the data when it's not that good. Okay, so now that's the Lost Galaxy of Copeland right here. And this is the Lost Galaxy. I'm not sure what that means, but, you know. Alright, so right now we got a lot of noise, and we can reduce that noise, at least temporarily.
Got another galaxy up at about 1 o'clock from Copeland's lost galaxy.
Yeah, right there.
Yep.
There's a lot of galaxies here. Uh-oh, we got a satellite. So I think that's probably going to be out of the frame, because it's going to be going this way, to the left. Yeah, that's right. Okay.
Donald Kunzer has a question for you.
Okay, let me see what he says. Donald Kunzer, Mark, I have a random question. In Armageddon, the asteroid was the size of Texas. Wouldn't anything that size be visible to the naked eye, or even outside the moon's orbit? Or to naked eye, even outside the moon's orbit? Actually, asteroids, Donald, they're actually black. You know that? They're actually quite dark. So it's possible that we wouldn't see it with a naked eye. But when anything has got some sufficient size, then there's a chance that the differences in the way the light hits it would make it more visible. So it's possible. But believe it or not, this is the thing about asteroids that people don't really get, and same with comets. Comets are bright in the sky; they have these beautiful tails, but what's really happening is the surface of comets are black. There's carbon compounds, and there's other compounds that are just black, and it's hard to believe that you can see it at all. So what they do is they take long exposures of the surfaces. That's why when the asteroid Ceres was photographed, there was one crater called Akatur crater, and Akatur crater had these two bright dots in it, and people said, look, lights on Ceres. It was just the way the photo was taken. The surface, being very, very dark, was overexposed to make it look gray. And when it did that, that gray surface ended up being brought to this level of gray you could see with your eye, but then the brighter spots, the real brighter spots that were in the crater, got hugely bright and looked like lights. And so that's why, for instance, in that case, it looked like lights. It was just a matter of the difference between the dark material and what were found to be salt deposits. I actually have a very big close-up of that whole crater, and you can see the salt. Basically, it's like a cryovolcano of salt compounds.
Oh, Akator on
yes.
Ceres?
Yep.
Yeah.
Yep. I actually have a 3D print of that crater behind me that I made with the little white spots.
Uh-huh.
Akator crater. Really cool crater. Let's zoom in on Copeland's lost galaxy, shall we? Well, who would not wax poetic over a galaxy like this? I mean, look at it. Wow. That's really pretty. All right.
If I remember right, the first time we looked at this, there was another galaxy, probably a Messier galaxy,
Okay.
that we looked at first, and they were actually quite similar and
Yeah.
similar in appearance. I don't remember what the other galaxy was now.
I don't either. But look at the spiral arms here, okay? Now, first of all, let's look at what kind of galaxy this is. All right, when you look at this lost galaxy of Copeland here, this one right here, okay, this is a barred spiral galaxy. All right, it's an SAB, and it's actually somewhat loosely wound. So it's a SA, meaning a spiral galaxy, but then these arms are kind of loosely wound. So instead of so it's given the SAB in the De Vaucouleurs ranking. But then it also has these loose spiral arms, so it has this SA capital B for barred, but then the C means that they're more loosely bound. Yeah, and if you look at Donald Kunzer points out at 12 o'clock, this arm of the galaxy is literally distorted by something, huh?
Yeah.
Absolutely right.
I would guess maybe that one up at 1 o'clock.
That might be. Yeah, we talked about this. This might be a companion galaxy. There's a second one. I think there's another companion galaxy to this one. Is this right here? Is this actually a galaxy?
You may be right. What was the number on this again?
This was Copeland's Lost Galaxy, and I'll tell you the number. NGC 4535.
4535.
Yeah. I don't remember, but I think that might be a galaxy in there. Maybe not, but I don't know. I can't tell. These photos are really not as good as they could be, but they still do the process. They still help me. All right. Yeah, I'm not sure. That might just be a spiral arm. I don't know.
It doesn't say anything about another galaxy there.
Okay.
Unfortunately, the picture is so zoomed in that can't see the outskirts of the galaxy.
Oh, and the one you're looking at?
Yeah.
Okay. Yeah, there's another galaxy right here. Probably an elliptical galaxy. And we have that one there, like you said. And that could be responsible. There's another one right here. There's the other one right there. See? We got 1, 2, and then 3. And probably more. Unless this is 1, 2. Not sure. Very cool, though. This is 12 stacked images. Very nice. Let's just try to draw out a little more detail here. Let me drag my black level in just a hair. Okay. Let's do this again. Oh yeah. That's nice. And then let's compress, pull out some data, see what's really there. This is way more than we would actually do. But you can see some pretty cool data that's there in the background. Then we'll pull it away. Interesting, you see these really big, beautiful spots of formation going on out here. This might be a H2 region, that is a hydrogen region, a stellar nursery. Very cool. Hey there, Rubiku, how you doing? Well, fantasy, at least you have a telescope to start looking, right? Fantasy said, for those of you that don't understand the power of this telescope, in my cheap $200 telescope, this would be just a white fuzz. Yeah, that's probably true. In fact, in most telescopes, it might be just a white fuzz. It depends on its overall brightness. But you can see some spiral arms probably. Wow. All right, meanwhile, while this is stacking, Let's go look at something else. Try and find something. Oh, yes.
Sombrero.
Yeah.
That's always nice.
That's where I'm going.
Okay.
I'm looking at this too to see what this is. And it's interesting, it's not selecting it, which means it's really not there. Okay. So Sombrero is selected, and we'll go there in a moment.
That's very pretty.
Yeah. Alright, so we got 16 stacked. We're going to pause this. I'm going to change the name here. First of all, I got to go back to get the number. It's an SAB, or it's an SA, oops, wrong galaxy. Copeland's galaxy I'm getting to. Just a minute. Here we go. Here we go. Lost Galaxy of Copeland. And this is 4535, and it's an SABC, so it's a loose barred spiral. NGC 4535. All right, and now we can save it. And we did 18 while we're waiting for that, so we're gonna just now go save it. Green bar shows you the FITS file. Again, a free viewer is available if you want to look at it that way. It's just a raw file. It won't be processed. This image here represents a processed image. So I'll save this exactly as seen, so you'll have it if you want to mess with it and check it out. So there we go. That's the Lost Galaxy of Copeland, which, as Daryl points out, isn't really lost. It's right there. Okay. 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 Let's go from 111% back to our auto fill. There we go. Get the full frame. Nice. Alright. And now we can go back to Stellarium and go to the Sombrero Galaxy, which is a rather interesting looking little galaxy. And it is not that big. But we're on our way. Here we go. Watch the telescope. You'll watch it change here. Here we go. Here goes the telescope. Okay. And we are gonna pull into the Sombrero here. zoom in. Oh, why are we still there? Okay. I must have reselected this again. Excuse me. Alright. Let's go.
Sombrero is just
It's just below
west
me.
of Spica.
Yeah, I should have actually, I didn't want to drive to it, but that's okay. Alright, here we go. Okay, there we go. Now let's go with the Sombrero. For real. Okay. There we go. Okay. Sombrero's a little bit south, and that's fine. We're getting our waypoint star, and then we will head to the Sombrero. I wonder if that's Porima. No, not Porima. Okay. Alright, well, there we go. Star below Algorab. Maybe it was Algorab. But now, the Sombrero Galaxy will be pretty obvious. And it may have wrong coordinates. Sometimes that happens. Let's go see. Oh, yeah. Wow, that's really far off. The database sometimes has the wrong coordinates for galaxies. So, that's not my fault. That's just what the database is defined with. So no biggie. What I'll do is I will, first of all, I'm going to change our speed to something that's a little faster. Let's go there. And then I'll come up. Okay. And go a little bit to the east. And head south again. I have to bring up our equatorial lines. I don't have to. But this will show me where we're going. Alright. Here, turn off those, turn on the equatorial lines. There we go. And now if I just go east, we should pull into the Sombrero. You're watching our star screen here. Okay. We'll see the Sombrero come into the frame. There it is. Alright. So for whatever reason, coordinates of the Sombrero are wrong, and that's the way it is. Sometimes that happens, you know. That's all right. So let's go back down.
I wonder if that depends on where you started from. We looked at Sombrero fairly recently, and I seem to remember you just drove right to it.
Yeah, I wonder if I drove right to it or if it went to it from the coordinates. I mean, it could have had a problem with the coordinate drive, so it's possible. The Sombrero is kind of small, but you know what? It's okay. It's going to look really pretty anyway. Because unlike looking at the Silver Streak or the Needle Galaxy, this one we're looking at it from a sort of a slightly different perspective. So you're actually looking it appears like you're looking down on it a little bit. Okay. And this one will benefit from just a 25-second shot. I don't think we need to go any further than that, actually. But we're going to wait until we get our star lock. So there we go. We're now guiding. So let's go and do that. So there, over there on the right side, you'll see our progress bar. Oh, it's 35 milliseconds. I should have said 25 seconds. Didn't do it. My mistake? Okay. Now the progress bar is going over here. You see the yellow bar is progressing. Alright, so we go into our live stack now in the Sombrero. And we will clear our last one. And then wait for the Sombrero to come in. This will look pretty.
Well, I think I may have to call it a night after this one.
Okay.
I have to get up early tomorrow. I got something to do.
No worries. There we go. Right, so this is the Sombrero Galaxy. And, yeah. So let's bring this up and let's... I'll bring that back. Yeah, we can call it after this one. It is 1:14 here.
Yeah.
I am so anxious to take some summertime shots and they're not here yet. You know. But that's how it always works, right? You always want what you can't see. That's alright. Okay, let's process this. There we go. And color correct. Not quite needed, but we're good. And now let's zoom in. Yeah, the meteor storm tomorrow will be streaming, and we're gonna stream from our all sky camera. And I gotta get someone out there to clean the top of the all sky because it's covered with bird poop. It's one of the problems, you know. Ay. But I have all day to have someone do that. So hopefully I can get someone there to do it.
How high is it?
You could reach it with your hand.
Oh.
It's about 8 feet. Not even, probably 7 feet up. Look at that sombrero. Look at that, huh? That's really pretty. And you can see there's detail, there's modeling in this dark lane. This is really pretty. And we're doing 25 seconds. And for 25-second exposure, it turns out it's even a little too bright because this galaxy is pretty bright. So we can actually try to cut down some of that a little bit. Yeah. So this is at the native size of our sensor. It's 100%. Yeah, the bird crap nebula. Yeah, I know, Michael. Yeah, I got to get that cleaned. It did slip my mind. I was actually thinking of making a little circuit that would actually make a cleaning run on it, like not windshield wipers, but just like a squeegee that would come up over the top. So I can 3D print an armature that would do that, and then I could actually attach it to a system and actually have it squirt water as it goes. So going, and over time it would actually clean it. That's actually pretty easy to do.
Former president of the astronomy club here.
Yeah.
Has an observatory up in a small town in the mountains southwest of here.
Okay.
And he has an all sky cam.
Okay.
And he's a member of the whatchamacallit, They watch for bright meteors, fireballs, and stuff.
Oh yeah.
He's a part of the group that watches for those and records them.
Okay. 200%, by the way, just so you know. That's a pretty galaxy, guys. Music is good for this galaxy too. This is called Relaxing Chill Music by Alex Productions.
Doesn't the Sombrero have two huge, like radial lobes coming out above and below it?
Oh, was it the Sombrero, or there was another galaxy we were looking at that has those radial lobes?
Yeah.
And they indicate a potential. Actually, it's our galaxy that has those radial lobes.
Well, yeah, ours does too.
Yeah, I'm not sure about the Sombrero. It might have. And those radial lobes coming out top and bottom are a sign of something back in its evolution, whether it was forming or going through the process that led to where it is now. Caused these radial lobes to be ejected north and south, and that typically is because of a supermassive black hole in the middle, and it could be related to that. So, and you know what? It might turn out that every galaxy has a supermassive black hole, which is perhaps why we have galaxies at all. You know, our galaxy has one. M87 has one. Other galaxies have them. So it's possible that it's a commonality.
It does have a central supermassive black hole. I don't see anything about the lobes I was thinking of. I must have had another galaxy in mind.
Yeah, there's another galaxy I know that has radial lobes too.
Yeah. Centaurus A does, I know.
Yeah, that's for sure. Which we can't see, and I tried, and man, that got me mad that I couldn't see it, but it's high enough. I think it's high enough. Let's do this. See, we're actually looking a little to the right of the meridian right now. And there's Centaurus A. Right there. Now let's see what its altitude is. It's a little past the prime, so to speak. It's plus 12. Should I try it?
I think it was too low last time, and it was higher up then.
You sure?
Yep.
I thought it was at like 10, but okay. Well, like I said, the lifting piers are going to allow us to look low. But you know what? At this scale, there's going to be too much air in the way anyway. The only solution is to just put an observatory in the southern hemisphere. Someone's got to do it. It's a lousy job, but someone's got to do it. Alright.
Yeah, even Virgo's getting over in the west now.
I know it.
Leo's pretty far in the west.
I know. I don't mind, because it means that something coming in the east is even more exciting to look at.
Oh, yeah.
Look. Because now we have Antares. Antares
there
is near the Refocusing Nebula. And Antares is at an altitude right now of 23 degrees. That's actually within our, just below our viewable limit. Just slightly below. And here's the Milky Way coming. Oh man, this is going to be, the summertime is going to be just a blast. So much fun. Alright, Before we do this, I do wanna just, for the record, I do want to go check out the Great Star Cluster in Hercules. I do want to look at Measure 13. But we are going to save this. This is the Sombrero Galaxy. Alright. Okay, the Sombrero Galaxy. Very cool. Alright, so let's go through and save the Sombrero. We'll pause it. Oh, I was one off. But that's okay. We're at 21, so we're fine. Alright, we'll save it. And then we will save it exactly as seen. There we go. And we'll come back and change our exposure to 1 second. And get rid of the stack. And do our beautiful 1 second shots here. Alright. Now let's go back to this planetarium shot here. Planetarium photo thing. Planetarium view, I mean. And head on over to Measure 13. And away we go. Boom. Star streaks galore. Here we are. And we'll just auto size. So there's the star that's going to become our waypoint star. What star is it? It's about to tell us. Eta Hercules. Eta Hercules, of course, from Alpha, Beta, Gamma, Delta, Epsilon, Zeta, Eta. Okay, Greek letters. In order of brightness, Alpha being the brightest. There we go.
Usually.
You know, but it can change. There's Measure 13. This is a very beautiful globular cluster. And we're actually going to just take, because we don't need to take a long exposure, we're going to just take a few 10-second exposures.
I remember last time we looked at this, it was surprisingly easy to see the propeller.
Yep, and it will be again. Alright, because we're actually pretty high in the sky. Alright, let's do a live stack here. Alright, and we're going to clear it. Get over here. Clear the live stack. And here comes the next image. There it is. Oh yeah, jeez. This never fails to just completely blow you away. And we have a galaxy right there. Very nice. Let's zoom in. What a beautiful cluster of stars, indeed.
There's the propeller.
You got it, can't miss it. And what's he talking about? He's talking about this shape right here. And if you want to see it better, I will dim the center of this cluster by taking the mid-level brightness over to the right. And now you'll see it even better. Now it's standing out very obviously. Right there is one piece, right there, and right there, and right there. So there's the propeller, as Daryl calls it. 3-bladed. It's not really a propeller, of course. It's actually just an area where there's not any stars in that particular area, and it just happens to look like the shape of a propeller.
Oh, I'm not the first to call it that.
No, not at all. But you were the one calling it that, so I just mentioned it.
Well,
Let's dim this out a little bit so we can see some of those stars a little better. We're going to go drastically to the right. Yeah, look at that. And now you can actually see those stars quite nicely. That's the globular cluster that is measure 13. Not bad.
Yep.
Figure while we're here, let's pull that over. Take a look at it at full screen, shall we? There we go. This is at 169, 159%. Yeah, 170. Here's 175% on our sensor. The guiding is beautiful tonight. We're having no problems with our guider. Look at that, huh? Look at the size of that cluster. It's a beautiful cluster.
Best globular in the northern sky.
It is. And Omega Centauri is the best globular overall. But we can't see it. Not yet.
Yep.
Wow. Alright, this is our native sensor size is 100%. We got obviously a lot more going in either direction. Not bad. We've stacked 17 already, by the way, because we're just doing 10-second shots. We'll go to 20. So let me get my telescope back here. There we go. So there's the telescope, and here's that. And now what I'll do is we're at 19, closing in on 20. There's 20. We're gonna pause. Save this. Alright, this FITS file is saved. And then we'll save exactly as seen.
Want to rename it first?
Yeah, I probably should have, huh? Because I just made it the Sombrero Galaxy again. So I'll rename it again. I'll do it right. I forgot to do that. I was rushing because I wanted to, because you want to go. So, alright, so M13 Globular Cluster.
Hurry on my account.
Oh no, it's alright. Alright, yes, so. Okay. Yeah, alright, no problem. I know what you're doing. Alright, so M15. We'll just do them again and it'll show up in the right place. I'll delete the others. Okay. Alright, now let's pretend I didn't do that and we'll do it again. Alright, so we'll save this again. Alright, and there's our FITS file stack, and now I'll save it exactly as seen. Alright, there we go. And our ping should have been saved. But if I don't explicitly say or see that it did, I always do it again. So save exactly as seen. Okay, now it's saved. Okay. So we can get rid of this. And the 1 second shot is here. There we go. And you can see the propeller in our live view too. See that? There it is. Very cool. All right. Well, guys, I think that's a good run for tonight. These are going to be up at the server. I want to thank all of you for coming. Izabela, thank you so much for all you do with our server to help us. And I look forward to everything else that all of you do for us. Donald Kunzer, enjoy your new mod title. You deserve it. And so do some of the others, which I shall do. I know Michael Klages, you probably could use that as well, because I think you've been here for a while. So, and some of the others have been here for longer. So I'm going to go through and add mods, add a lot of you guys as mods again, because sometimes it gets taken away if you don't use it. It can get taken away from you, and that's another issue. All right. Well, folks, I enjoyed having you out here tonight, as I know I'm sure you did too, Daryl.
Oh, yeah.
So thank you guys, and we will see you on the next stream, which will be tomorrow night, where we're going to do the meteor shower. If it's a meteor storm, we're going to have some pretty exciting footage through the course of the night.
Hey.
Yeah. So let's hope I can get that thing cleaned. Oh.
Keep my fingers crossed.
Yeah.
I don't think the weather's going to cooperate here. If it does, though, I'm probably going to be running outside taking a look.
Well, it's always clear out there. I'm very rare that I have a cloudy day out there.
Yeah.
But
okay. Well, thanks for having me, Mark, and
yeah,
thanks everybody for coming. It's been a great night, and hope to see you tomorrow night.
Okay, guys, we'll see you later, and come again. All right, and that can be pretty soon. All right.
Have fun.
Thanks, guys. Good night.
Good night.